Hello Math Studies students, and welcome to our second video on sets. In this video we will define set builder notation, and we'll talk about universe and complement in the context of sets. Also, we will talk about the IB project a little further, specifically how to write a plan for the IB project. All right, so the next assignment for the IB project is due by the start of class on Friday, November 8th. So 2 classes from when you're watching this video for. And then B days, it'll be the following Monday. For this assignment, you'll be writing the plan to your project. And I've given you a little bit of a guide as to what you want to do when writing this plan. Again, you're going to upload the plan to the SLC. There'll be a little Turnitin hand symbol, and it'll be titled Project Plan. And you need to upload that by those dates that I just previously had up here, next Friday or Monday, depending on whether you're an A or a B day. So what should be in the plan? Well, the plan should be a 1 to 2 paragraph in length. It can be longer, but I think, if you're writing well-written, concise sentences, you shouldn't have any problem getting it done in 1 to 2 paragraphs. And it's going to explain what you will do in the project. You want to write in future tense, and you're going to use first-person narrative, meaning you're using I to explain what you will be doing. So start off by restating your statement of task. I will investigate the relationship between blank and blank, or whatever you're doing. And that will sort of set you off, essentially, like give you a focus for what you're writing in the rest of the plan. So how will you investigate this relationship? Well, you'll need to gather data. So you need to talk about how you will gather the data. Most of you will be writing a survey. And so you'll say, I'm writing a survey on, my variables. And then you want to talk about how you are going to distribute the survey and who you're going to distribute the survey to. If you're just giving it to high school students here at Reagan, say that. Talk about, are you going to give it to students before school in the waiting area in the cafeteria, or are you going to do it during your lunch hour or during an ELO? Or is it not even going to be at school here? Are you going to go to a mall and hand out flyers or the surveys? Or are you having someone help you out, like a sibling or a parent at work? But talk with some detail about how you're handing the survey out and who you're handing it out to. Once you've collected your data, you need to organize it, and in the plan you need to say how you're going to organize it. So most of us are probably going to do a chi-squared analysis. So in order to do a chi-squared analysis, you'll have to arrange your data in a table, specifically a two-way table or a contingency table. And once the data is organized, then we get to start doing the math, arguably the most important part of the whole project. So talk about what mathematics you're going to use to analyze your data. Again, many of us will be using chi-squared. And so we want to say that. And more importantly, to go along with those mathematics is, why are we using the mathematics? Well, if we're using chi-squared, that would be to show that there's a relationship or to show that there is not a relationship. Test for independence, essentially. And that's why we're using the math. Now, you can add more to this plan later on. Most likely, we'll end up doing multiple mathematics in our analysis. And so if later on you decide that you're also using percentages or something like that, you can add a sentence or two explaining what other math you're doing and why it's relevant to the project. But this is a good start to it. And once you've completed this along with your statement of task, you basically have written the introduction to your paper, which along with the title is worth up to 3 points. We just need to make sure that we're following this plan as we move along. If you change your statement of task at some point, you want to revise this plan. If you decide that the plan isn't totally exactly how you're going to do it, and you decided that you're gathering your data in a different way or with different people or something like that, then you'll just go back and change it. But once you have it written, you can then edit and change and do all those sorts of things. I need your first draft of this plan uploaded to the SLC, again, by either next Friday for A days, this coming Friday, or the following Monday for B days. All right, so the other part of our learning intention outside of the project was to talk about something known as set builder notation. Set builder notation is nothing more than a way of explaining this sort of notation that we've seen before. Let's start off with this first example here. We've got this set A. We know it's a set because it's defined with a capital letter, and then they're using these braces or the squiggly parentheses to sort of set off the set. So we know that we have set A, or actually I'll just write it as I read it. So we have set A is, or is defined by, or is equal to, any of those things are defined. And then they've got this X here. X is all the possible values of the set. And so X, and then they have what we have previously referred to as the given symbol, a vertical line. It's not a division symbol. You can read that as given or defined by or such that. So we have set A is equal to all values such that, or the set of all values, again, this indicating set. X is between -2, we always start with the lowest value, and +4, inclusively, or including -2 and 4. How do I know it's including? Because with our less than symbols, we also have an equal. Now, whenever they write these intervals, they're always going to start with the lowest one, which means they always have to be using some sort of less than sign. It just comes down to whether is it less than or equal to, or just less than. And we've defined it for X being an element of this big Z, which we know from last class means integers. So X is an integer between, or our set contains all values of integers between -2 and 4 inclusively, or including -2 and 4. Another way to read this is how I have it typed right here. The set of all X such that X is an integer between -2 and 4, including -2 and 4. The set A can be represented on a number line as shown here. So we have our line, and then they have put little points on all of our integer values. Right there at the 2, the -1, so on and so forth. Integers, again, are whole numbers, and they're opposites. So it does not include anything in between these whole discrete values. And so we only have 7 numbers. So we call this a finite set, to use some vocabulary from last time. And we can notate that saying n, the number of terms in A, or the number of elements in A, equals 7. And that is, again, a finite set. Looking at this second example here, we've defined set B is the set of all, this time we have real numbers. So X is an element of all real numbers, such that X is between -2 and +4, and it includes -2, but it does not include +4. This is what we'd call an infinite set. The reason it's infinite is because it includes all real numbers, and real numbers can be any numbers. So if you think about even from -2 to 4, sure, you could have -2, -1, 0, 1, 2, and 3. We don't actually include the 4 because there's no equal sign in front of it. But we could also include all the decimals in between those values, such as -1.5, -0.047, 0.123987, just any number in the world between -2 and up to 4. So we aren't going to list these all out. That would take forever, quite literally. So instead, we can indicate it on a number line. As we remember from algebra classes, if we want to include a value, we use a closed circle. If we don't want to include a value, we use an open circle. And so we want to include all values starting at -2 and then up to +4. So it would include numbers like pi. It would include numbers like the square root of 2. It would include numbers like -1/2, and so on and so forth, as well as all those whole numbers or integers that I had mentioned previously. Yep, and we can't count up the numbers in the set. It's an infinite set, totally continuous, and so we say the number of elements in set B is infinite. So that is two examples of set builder notation. Last but not least, I want to talk a little bit about complements and universe in the context of sets. We know from our probability chapter, the symbol U is used to represent a universal set. It's a group. It's what we're talking about. Includes everything. The word complement, we know, is notated with a prime symbol. It means not. So in the terms of sets, it's all the things, if we're talking about the complement of A or not A, it's a set that's still part of our universe, but contains everything that's not an A. So an example of that would be if I have my universe or my universal set defined as the integers 1 through 8, and set A, which includes the numbers 1, 3, 5, 7, and 8. The question is, what would A prime be equal to, or the complement of A? Well, it's going to be a set, and I want to include all values that were not an A, but were still in my universe. Well, 1 was an A, 3 was an A, 5 was an A, 7 and 8 were an A. So what's left? Well, I've got my 2, I've got my 4, and I've got my 6. So 2, 4, and 6 are the elements of the complement of A. And that's an example of using universe and complement in the context of sets. I would recommend looking at these problems, especially the ones on the set builder notation, which is the first part here, 3 and 4 on page 216. And then on page 217, it brings into the notion sets with dealing with complements and universe. And then last but not least, I have a little bit of Venn diagram notation, which again we covered in our probability chapter, but you may want to look at this again in the context of sets. And this is the end of what I'm going to talk about for sets for our unit. So we have a test coming up. We won't take it next class, but we will take it the following class, the same day that your plans are due up to the SLC. And again, those plans should be loaded to the SLC by the beginning of that class.